with 1-2b here. We're going to talk about a lot of different properties today. I know those are the fun things, right? Where you get to just name a bunch of properties, but it helps us get to other end goals and just be able to simplify things down the road. So first thing we're going to do before we talk about those properties is just take a look at a number line and just get some number sense, right? We need to understand what the value of a number is. So the first thing we're going to do is a little bit of graphing on a number line. So we're going to do this first one together, and then I'm going to have you try the second one on your own or with a neighbor and see how you do. So this says graph the following numbers on the number line below. Any ideas as to what might be a good method for taking these three numbers and placing them on this number line? What would your first instinct be to do? John?
You want to make them all the same thing.
Same format, right? Simplest format to do that in would be, anybody? Which of those three formats do you think makes the most sense for those three numbers? The first number, second number, or third number? The third number, the decimals, right? It's easiest to turn a number into a decimal because your calculator will do it for you. Isn't that lovely? So if you have a calculator and you would like to get it out, great. That first number, you might know that one off the top of your head, right? -5/2. What's the decimal version of that? You may plug it into your calculator if you're not sure. What is the decimal version of -5/2? Do you know how you plug that into your calculator? Yeah, -2.5. You would plug in -5 divided by 2, right? So -5 divided by 2, that would be a -2.5. What do you get when you plug in the square root of 2? Do you all know where that square root button is on this fancy schmancy calculator that you bought? See the x squared button? It's right by that x squared button. So second and then that x squared button. And what do you get? 1.4. You don't have to round further than that on this because there's nothing close to 1.4 elsewhere. Sometimes you might have to round a little bit further. Just pay attention to your other numbers. And then this one is 2.667. That doesn't change, okay? Now here's the deal. I asked you to graph these numbers on the number line. So just make sure that when you put it on the number line, you put it in as these numbers, not as the decimal version, okay? Because I want to know that you understand where those numbers relate on a number line. So what's going to be farthest to the left on this number line? -5/2, okay? And I like to have a 0. So I would probably just go like 0, 1, 2, 3, space them evenly, okay? So that it makes sense. And just make sure that you have all the numbers that you came up with there. So I would put in 0, 1, 2, 3, -2, -1, -2, -3. I'm not super picky that you put all of those numbers in, but I do want to see that the spacing is about what it should be, okay? So -2.5, that's going to fall right here, okay? So we're going to call that -5/2. Then we have that rad 2, square root of 2. Sorry, when I say rad, it's the radical, right? A radical is a square root. So rad 2 or the square root of 2, same thing. So the square root of 2, we said was 1.4. So that's going to be not quite halfway right here. But remember, you write it in as the square root of 2. And then 2.667, that's 2 2/3 of the way. So that's going to be about here, 2.667. Okay, so that's what I want to see when you plot them on a number line. You may put a point, you may put a little hash mark. I just want to see that you know where they're landing, okay? Okay, so you, with a neighbor, without a neighbor, check with a neighbor at the end. But if you want to graph it on your own first, that's fine. Go ahead and plot those three on that bottom number line. Remember, your calculator is your friend. I will tell you when we get to things where you won't be able to use your calculator, but if you're able to use it, by all means use it. Just make sure wherever you're putting those points that you're labeling it with the number that was given. Check with your neighbor. How'd you do? You got the same answers? So I want to come up here and graph it on mine? Or you want to tell me where it is? Yeah, thank you. This is the day that you're not supposed to show up late because we start late already, right? Couldn't get yourself out of bed this morning? All right, negative 1.44. Where's that going on this number line? To the left, between the negative 1 and the negative 2, not quite halfway between, right? Just, slightly to the right of halfway. So we would call that negative 1.444. I don't need you to write all of those in. He is not here.
Okay.
He's not here until next week. I'm sorry, I should have replied.
No, that's totally fine. I will,
Christian, right? Is who you were looking for? Yeah.
Have fun.
Yeah. Okay. The next one. So square root of 3 and 1/3. What did the square root of 3 come out to? 1.732. Okay. What's 1/3? 0.3 repeating, right? 0.3. So where is that 1/3 going to go? Between what two numbers? The 0 and the 1, right? 1/3 of the way. So that's right here, 1/3. And then rad 3 is 1.7, so that's more than halfway between 1 and 2. So that would be here. So that's the square root of 3. So square root of 3, 1/3, and negative 1.44444444. Any questions on that? Okay, let's compare some numbers. So example 3 here, it says compare the numbers using, what are those symbols called? Greater than, less than, in this case, less than or greater than, right? What is the square root of 17? 4 what? 4.1. Okay, does anyone know a way that you could figure that out, what symbol goes here without using your calculator? Because I don't expect you to know the square root of 17, but do you know something close to that? 16, right? What's the square root of 16? It's 4. So if this is greater than 4, right, because it's the square root of 17, it's going to be a bigger number. That means that if this is a number bigger than 4 and I know this is less than 4, I didn't even need my calculator. I know that 3.8 is going to be less than that, right? Now, use your calculator. You are more than welcome to use it. But just know there is that mental math you could do that will make it a really quick problem, okay? What did we say that came out to? 4 point, I don't want to throw you off thinking it's 4. 4.123, okay? Okay, now here's where all the mistakes get made. Why do you suppose in letter B here we get a lot of mistakes? Negative, okay? Because when we work in the negative world, the numbers that look bigger are actually smaller, right? When you move to the left on a number line, the number looks like it's getting bigger because the absolute value of it is bigger, but the number itself is smaller, right? So square root of 26, again, if you wanted to do a little mental math here, square root of 26 is real close to what? The square root of 25. So this is probably close to negative 5, but you can always plug it into your calculator. So the square root of 26 is 5.099. but it's negative, right? Now, if you looked at those numbers without the negative sign, God bless you. Are you allergic to me?
Yeah.
Sorry. If you look at those numbers, we would say, oh, 6.25 is bigger. But because we're negative, it's actually smaller, right? So the symbol you're going to put in there is negative square root of 26 is greater than a negative 6.25. Okay? Questions on that? Okay. Here's what I want you to do. I want you to look at these properties for a minute and just think, do I know any of these? Because you learned them all in Algebra 1, I promise you. Like, if you didn't, I don't know what school you went to because I promise you've seen, now not closure maybe. Closure is not a real popular one, but you've seen commutative, you've seen associative, you've seen identity, you've seen inverse, you've for sure seen the distributive property, right? Okay, so in your head, or maybe scratch in a little note, I want you to write down or think about what is that property. See if you can place any of those properties right now, okay? Feel free to chat with a neighbor if you're not sure and you want to run it past them. If you can give me a property, I'll give you a Jolly Rancher. And you don't have to give me like numbers or letter, like you can just speak it to me in words, what it does. That's okay too. Anyone want to take a crack at one of these? John?
That distributive property.
What is the distributive property?
It's when like, you have to.
Do you want to come write a sample up here for me?
Let's try it.
Okay, do it.
Okay.
You need a marker, huh?
Oh, okay. Hey.
Welcome.
Okay, so this is the multiplication one, right? So we got like a 5.
Mm-hmm.
We got like the little parentheses guys.
Right.
Got a 3 plus 2 or something.
Uh-huh.
And this guy goes in here.
Uh-huh.
And equal whatever 15 and then 2. Like 25 or something.
Not 25. 15
15.
plus
10.
10. Oh, you're saying the final answer.
Yeah.
Gotcha. Yes. I'm saying what does the property look like? So he's saying you take 5 times 3 is 15 plus 5 times 2 is 10.
Very good.
Distributive property. Thank you. Okay, so let's write this down. I'm going to do it with letters just so it works for anything. So if I say A times B plus C, right, that becomes A times B plus A times C. Distributive. Who's got another one? Jessica, which one?
Inverse is like the opposite of what it says.
Inverse is the opposite. Okay, can you give me maybe an example of what that would look like?
It's like A times C, the opposite would be 2. I don't know.
Okay, I see what you're saying. Not exactly, but I like where you're going with it. Yes, inverse and opposite makes sense together, but it's a little bit different than that. Anyone have one? John's gonna go for it again.
Isn't identity like the same thing twice? Like it's the same number, like multiplied kind of like by itself forever?
Not by itself. It is something to do with the same number.
Isn't it like a number times 1 equals the number?
Yes. Identity, I always tell people, think of it like you are who you are, right? So what happens around you hopefully isn't going to change who you are. Like Brooke is still Brooke. So Brooke plus what is still Brooke? 7 plus 0 is still 7, right? What is it with multiplication then? 7 times 1 is still 7, right? Good job. You make it a Jolly Rancher. So identity property is either A plus 0, so something plus 0 will get you that same thing back, or A times 1 will get you that same thing back. So notice one's addition, one's multiplication, right? Anyone want to shoot for another one? All right, let's do it. The closure property doesn't really show up much, but it's there. I will give it to you. Basically, what the closure property says with addition is if you add two numbers together, you get a real number. What's up, John?
I just have a question.
Yeah.
Are we doing any proofs this year?
No.
Alright.
So A plus B will get you a real number. Real number plus real number will get you real number. Same thing with multiplication. A real number times a real number is a real number. Okay. Commutative property. I always use this with like your commute to school, right? If you start at school, or start at home, end up at school, your distance is the same as if you start at school and end up back at home, right? If you take the same route, you go the same distance. It's just in reverse. So commutative with addition just basically says A plus B is the same as B plus A, right? Flip them around. You could do it with numbers. 2 plus 3 is the same as 3 plus 2. Okay. Same goes for multiplication. If I multiply A times B, it will be the same value as B times A. Anyone remember the associative property? Or what it entails? There are always what symbol in the associative property? Remember? It's parentheses, right? There's always parentheses with the associative property because basically they're just putting things in a different order. So A plus B plus C is going to be equal to A plus B plus C. So in the first one, we're adding the A and B first and then the C. In the second one, we're adding the B and C first and then the A, but you will get the same value. Okay? So really just changing the order. Same goes with multiplication. If I go A times B and then multiply by C, it's the same as if I multiply the B and C first and then multiply by A, right? Just doing a little PEMDAS here. Okay, and then inverse, much like, was it Jessica was saying, is opposites. It is opposites. There's opposites going on. Basically, it's saying if you take a number and you add the opposite of that number. So 7 plus negative 7 is what? 0, right? If you add its opposite, you'll always get 0. So the inverse property of addition, you always get 0. The inverse property of multiplication is if I take A and I multiply by the reciprocal, 1 over A, I will get what? 1 times, no, that's a bad example. 2 times 1/2. What is that? 2 times 1/2 is 1. Thank you, Noah. Okay, so that's the inverse property. And that's as long as A doesn't equal 0, because you can't divide by 0, right? So 1 divided by 0 doesn't work. All right, questions on that? All right, you have 4 properties there. Talk to people around you. Tell them which property it is, and you must talk to somebody. And if somebody isn't talking to someone, reach out to them and be the person that talks to them, okay? Talk about those 4. What are they? And you may look at your property list while you do it. All right, hit me. What'd you get for A? Inverse of multiplication. A is the inverse property of multiplication. You may just put the times symbol for multiplication and the plus symbol for addition. I'm fine with that. But something times its reciprocal equals 1. That's inverse, okay? Letter B. A lot of people do this one wrong. It's commutative, right? A lot of people think associative because there's parentheses there, but look at what's actually happening. The 3 and 4 got switched to a 4 and 3. We're not multiplying by a different thing. We're just changing the order inside of our parentheses, okay? So our parentheses didn't move. What was inside the parentheses moved. So that is commutative of multiplication. Letter C. What'd you get for C?
Distributive.
That's the distributive property, right? If you look at how we got from the one to the other, 3 times G is 3G. 3 times H is 3H, right? Nothing else changed. So that's the distributive property. Man, I can tell I haven't written all summer because my handwriting is horrendous right now. I'm really sorry. I'll work on it. Letter D, what'd you get? Associative, right? The parentheses moved to different numbers. The 4A is still there, but now there's an A inside, whereas before it wasn't. So when your parentheses move, that is the associative property of what? Addition. Associative property of addition.